Today we're going to talk about exponential functions. Exponential functions take the form f of x equals a times b to the power x. Of course, since it's a function of x, x is going to be our variable, our input, that will give us our dependent variable, our output. A and b will be constants. We're going to talk about a and b today and how to put those together to write an exponential function. The constant a stands for the initial value, and the constant b stands for a growth factor, and we're always going to think of b in terms of percentages to make it easy. So a is the initial value, where things start, and b is the growth factor. We're going to talk about it as a percentage. Example 1. A town has a current population of 10,000, but has an expected growth rate of 4% annually. Write an equation that models this situation. Please notice we called the b the growth factor, and here we're talking about a growth rate. So I want to be clear on the difference. Our initial value, which is going to be 10,000 in this case, and our growth factor, which remember begins at 100%. We have a growth rate of 4%, which written as a decimal is 1.04. Those are the two parts of our exponential equation, a, the initial value, and b, the growth factor, which is changed by some rate. Let's look at another example. Example 2, an experimental population of bacteria begins at 475 million, but is being killed by antibiotics at a rate of 1% per hour. Write an equation that models the population as a function of time in hours. So to write a exponential equation, again, we're going to look for an initial value and a growth factor. Our initial value, our b, remember, the growth factor begins at 100%. In this case, we are losing 1% per hour, giving us a growth factor of 99%, or written as a decimal, 0.99. Our function then would be 475 times that 0.99 to the x power. Now notice we have a couple choices here. I went with 475 and stated where f of x is millions of bacteria, instead of putting the 475 million in here. We don't have to do that. We could have put the whole number, 475 million, in here and had people do the math. But I'd prefer to use this shorter formula and let people know that whatever answer they get is in millions. Example 3. Anne has $400 in her account. Every month she will deposit 5% of whatever the balance is. Write a function that models Anne's account balance based on time in months. Our initial value is $400. Our growth factor starts at 100%, and here we have an increase because Anne is depositing, giving us a total of 105%, or written as a decimal, 1.05. Our exponential function then is 400 times 1.05 to the x power. Hopefully this has helped you see how easy it is to write an exponential function for a given situation. Thanks for watching.